Greetings and welcome to this week's webinar on CS162. We are recording this again because last night we did this live for the students, but it didn't record. So we're giving it another shot, and I'm just going to run through this with you. It's going to be a little bit faster because there aren't any questions to be asked because there's no one here but myself. So if you do have questions after this, just ask them on the Collaborative or the CS100 Piazza forum, and we can answer your questions there. So first, let me introduce myself. My name is Eric Ianni. I am done with this program. I graduated in last summer, or this past summer. I did the one-year track, and I was lucky enough to be asked to stay on as a tutor. I was a peer mentor for 3 terms, and I really enjoyed it, and that's not surprising considering my background is I was a high school Latin teacher before I joined the Marine Corps, and then I got a GI Bill, and so my wife's a doctor, she doesn't need it, so I went ahead and used it for something I always wanted, which was a computer science degree. So this allows me to be involved in teaching people, so thank you for giving me this opportunity. Now we're just going to jump right in. All right, operator overloading is a complex concept, so I'm going to try to break it down for you. So let's talk about the second part of that phrase, overloaded. If you overload something, you're generally pushing it beyond its normal parameters. You're making it do something or hold something that's beyond what it's not recommended, but what it's designed for. So, for example, if you have a truck and you overload the bed of the truck, you've exceeded the maximum load. You've overloaded it. If you overload an electronic device, you're giving it too much electricity. That might sound a little weird when it comes to operators, but again, you're pushing it, you're making it do something it wasn't originally designed to do. You're asking it to do something originally designed to do. Now, with the example of the truck and something electronic, you might break something if you overload it. In computer science, and especially C++, when you overload an operator, there's no danger. Well, there's some danger if you try to overload something in a way that isn't expected. We'll talk about that. But you're just asking an operator to do something it wasn't originally designed to do. So the definition here is operator overloading is redefined as a C++ operator for a class or enumeration operands. We just wanted to give you a textbook definition. What this means is we can use operators, and those include things like plus sign, negative, minus sign, equal sign, the equality symbol, equal, and it even includes the less than, greater than. Those are operators. And if you Googled C++ operators, it'll give you a long list, and they're actually in your book as well. And these all can be overloaded. They can be given new purpose. And the reason we choose to do this is that there's a conventional notation for adding things together. So it makes sense when you have an integer plus an integer, it adds them together. That's just the way our brains are wired. It's tradition, it's convention. Same thing with string adding. In C++, you can add 2 strings together and it'll output them as one. So again, that's the addition symbol. We see it and we know what it's doing just by its very nature that it's a plus symbol, and it has that connotation, that convention associated with it. So when we make our own classes, we can give these operators, we can use these operators in such a way that the behavior with those operators can be guessed at by the person using our code. So let's look at an example. So here's the first example. This is taken directly from your book. It is on page 725 if you have the 8th edition. And this is a class. It's called number array. The class has two private items. It has a pointer of type double, and that's the APTR, a pointer. And then it has an integer to store the size of the array. So what's going to happen is we're going to create an array, and it's going to be pointed to by a pointer, and it's going to be an array of doubles. Now, this is where a concept called deep copy and shallow copy comes into play. If we were to just use the assignment operator, that's the equal sign. Don't call it the equal sign, it's the assignment operator. Or sorry, don't call it the equal operator, because that is the equals. So we're talking about the assignment operator, where you assign one value from the right-hand side to the left-hand side. So whatever's on the right-hand side, we're going to store that information what's on the left-hand side. Now, when you have integers, it just, you can say x equals 5, and it takes 5 from the right-hand side and stores it on the left side into x. Now, shallow copy, if you don't overload your own operator, your assignment operator, what's going to happen is you're going to get something called shallow copy. The compiler in the program is going to do its best effort to copy stuff. Now, when it copies this number array, it's just going to copy everything and move it on over. So int array size will be copied over correctly because it's just an integer, and integers hold numbers. But what do pointers hold? Well, they hold memory addresses. So if we just use the normal assignment operator without overloading it, we're going to have the address from the right-hand side a pointer copied into the address of a pointer on the left-hand side. So now you have two objects that are pointing to the exact same place in memory, and that's not the intended functionality you want. You want them to be different. We want each of these number arrays to have its own pointer with its own memory address. Otherwise, if we change one, it changes the other. And that's called a shallow copy. So we need to make sure we have deep copy, and that's why we have to overload this operator. So again, on the left-hand side, we have two private members, and then we have a public, and there are other functions in here, but the one we're concerned with is the overloading part. You overload, in this case, you void operator, and then whatever operator you're changing. So in this case, we're using the assignment operator. So we operator equals, that's the operator we want to change. And then we have const number array, and we're passing right into it by reference. Now, we call it right because this will be whatever's on the right-hand side of the assignment operator. So, and then when we come over here to the actual code for the overridden operator, it's very similar to what you do when you write any other implementation code. Return type, the class it belongs to, scope resolution, and then again, operator equals, and then what we have here. Now, you might want to know why we're using const. We're using const because if you don't need to change something and you pass something in by reference, you want to make it const in case, just so you don't accidentally change it. And remember, you're supposed to be passing things like objects that are complex by reference so that you're not copying them all over again, because you could run into the issue of a shallow copy. And also, you don't want to continually have copies of very big objects because it takes up a lot of memory. So in this case, we're passing by reference, and we're making it const so that we don't make any changes on accident. All right, now we'll get into the code. So we need to run some things here. Okay, so notice it just says array size. It doesn't say anything other than just array size. All the members, array size, a pointer, those will all refer to what's on the left-hand side of that assignment operator, or left-hand side of any operator. So when you say if array size greater than 0, it's saying if the array size of the one on the left, is greater than 0, do this. And what we're going to do, we're going to delete the whatever's currently there, because we don't care what's there. We're not saving. We're just going to copy the right-hand side into the left. All right. So now we get the right-hand side, which is represented by right, and we get that array size stored in array size for the left-hand side. And we create a new array, and we have point A pointer at it. So this creates a new array of the size of the right-hand side. And then we are just going to loop through the right-hand side's array, and we're just going to copy from the right to the left. And this is how you're going to copy all the stuff over. And this is your deep copy. This is the way you should be doing it. So if you have any class that you write that has things that aren't primitives, and primitives, in case you forgot, are your numbers, your integer, your double, your long, things like that. Also, a char is primitive. If you have anything other than there, especially if you have arrays, and double especially if you have any sort of dynamic memory, you need to make sure you create an assignment operator. You overload the assignment operator if you plan on doing anything assigning one object to the other. Otherwise, you're going to get shallow copies, and it's not going to have the functionality you want. Again, that's a lot I just went over. This is in your book, and they break down each section of this for you. All right, so we also made a second example using a different operator. All right, this time we use the equality operator, and that's the equals equals. So we're using the exact same class we had before. All right, and notice I apologize. Right here, where this void here for the equality operator, that should actually be Boolean. This should be Boolean because the equality operator returns something. The assignment operator doesn't return anything. The Boolean needs, or the equality operator needs to say, are they equal or are they not? So I apologize for the mistake. So this void here needs to be Boolean, and it shows it correctly in the second box here. So we do something similar. All right, for the prototype, we have the const number array A, and we have const number array B. So instead of left and right, we actually need to pass it two of these. We have to pass it two objects, in this case A and B, which will be the left and the right. All right. So the first thing we check, if A array size does not equal B array size, there is no way they can be equal because they have different number of elements. So we just return false right away. And this is a good example of efficient code because there's no reason to go on to the loop if you know it's already not equal. So now we go into the loop and we just compare each element one by one from A and B. And if any of them are not the same, we return false. If we make it all the way through the loop, we're going to have to return true because we know that it is true, because the only way that you can get to that line is if it makes it through the for loop without returning false. So this is a second example. There are many, many ways of doing stuff. You can overload the plus plus operator. A good example of that would be, say you had a class that was a date, a day, day, month, day, year, and you wanted to allow the programmer to do plus plus and have it move to the next day of the year. You can do that, and that's, if we go back up to the top here, that's convention. It makes sense to, if a plus plus, we know it adds 1. If you add 1 to a date, well, that means it's easy to guess that it's going to go to the next day. So that's that convention we're talking about here, and it makes, and that brings us to the convenience, efficiency, and clarity. since we can guess what it means, it's clear. Since we have added the plus plus, it makes it easier for the programmer. It's convenient, and when things are convenient for programmers, they can code efficiently. So that covers this here. All right, so that's the second example. If you need more examples, again, they're in your book. You can find them also online. All right, so let's talk about inheritance. This is the other thing you were covering this week. Inheritance, if you think about it, what the word means in English, it means we inherit things from our parents, right? My dad is tall, therefore I'm likely to be tall, so I inherited my last name from my parents. So there's these types of things. It makes sense, and we name things in computer science things to make sense, and so it's not hard to understand. So when we deal with inheritance in computer science, and especially in C++, this means there's going to be a parent-child relationship. And some other terms they use, instead of parent, they call it the base class. It's the base one. It's the highest up in the hierarchy. And then there are derived classes that inherit things from the parent class or the base class. So you can inherit a lot of different things in a derived class from the base class. You can inherit private data members. You can inherit functions as well. So let us look at an example. Oh, I apologize. Why do we want to do this? It allows you to reuse code. So you can say you have a generic animal class. So you have an animal, and animals, all animals will have certain traits. But you want, okay, now I want to add to, say, my database or my program, I want to add a mammal class. I want to differentiate mammals from reptiles. So we know that mammals and reptiles are both animals. So they inherit the same basic traits from the animal class. Things like number of eyes, like animal could have eyes, because even if you don't have eyes, you can just have a 0 for that attribute. And then so we have mammal, and then we differentiate mammal from, like, cold-blooded reptiles, So mammals can be warm-blooded, reptiles can be cold-blooded, and that's a trait that's different. And then we could break mammals down, but every mammal down, say a cat and a dog, they will all inherit that warm-blooded trait that is from mammal. And so you start getting these like pyramids of classes as you go further and further down, further and further down in inheritance. This allows you to reuse code. It also allows you to make small changes to code. It's like, yeah, I had that dog class, but I want to be even more specific. Instead of writing a completely brand new class, you can inherit from the dog class and tweak it and make it like a poodle or something. So it's convenient for us, and it makes logical sense, and it's going to come into play with something called polymorphism. And I don't believe it's covered this week, or sorry, I don't believe it's covered next week, but the following week. And this is a very, very powerful tool, and it absolutely requires inheritance in order to function. All right, so now let's look at an example. All right. This example is used very often. And so what we have here, over here on the left-hand side, I have bolded. This entire class is bolded, and it is going to be our base class. The base class has number of sides, and it also has one function. It's getArea. All right. Shape, it makes sense because all shapes will have to have some way of finding the area. A circle finds its area differently than a square, and differently than a triangle. All shapes can be described by the number of sides, even if that is 0, like in a circle or an oval or ellipse. So in this case, we have a square. All right. So square here, notice I don't mention again number of sides, and I don't mention getArea, because it inherits those from the base class. So I don't have to declare them again. And right here at the bottom of the left-hand column is our constructor. Every time I create a square, it's just going to make it have 4 sides. And again, I don't have to declare it here in the private section because it's already up here in this base parent class. Now I come over here, top of the right-hand column, and we have the first get area function. And this might seem similar. We're overriding it. We're saying when we're talking about squares, we're going to use this get area function, not whatever's in the base class. So again, this has something to do with what we talked about earlier, overloading. It returns the length times width. Makes sense. That's how you find the area of a circle, sorry, of a square. That brings us to a circle. Again, notice the private members of a square, we have double length and width. But for a circle, they don't have length and width. They have radius. That's how we define or describe circles, by their radius. So notice they're both shapes. They both have number of sides, but squares have length and width, and circles have radius. And again, when we have our constructor down here for a circle, we set number of sides equal to 0. And then down here, we return pi times radius. So pi r squared is going to be what we return. And again, it overloads the shape get area function and uses the one for circle. So if I have a circle object, and say I have a circle object called A, and I want to get the area, I do A dot get area. If I have a square object called B, I do B dot get area, and they will know which class they are, and they'll use the appropriate function. So this is where polymorphism comes in. I'm just going to talk about it briefly. Say you wanted to have an array of both squares and circles, and you wanted to display the area of everything in that array on each line. Well, when you declare an array, you can only give it one type. You can't give it, oh, I want this element to be a square and this element to be a circle. You can't do that. But what you can do is you can make an array of shapes. And a square is a shape. A circle is a shape. So technically, you can put squares and circles into the array that is defined as array of shapes. And now we have multiple types of objects in one array, and that normally would seem impossible, but with polymorphism, it is possible. Now, if I wanted to display the area of each of those one at a time, I just loop through the array one at a time using a for loop, and on each element of the array, I can call get array or get area. And it's going to know, well, this element is a circle. I'm going to use a circle get area. This element is a square. I'm going to use a square get area. That's polymorphism. I don't want to go any further into it because it's a complex topic and it will be covered later. So that is the end of this presentation. I know we covered a lot. If you have questions, ask them on the collaborative or the Piazza CS100 mentoring forum. So everyone, thank you for joining, and we plan on doing more of these in the future. Take care.